Here we go. Let's take a look at 4.1. Write down the coordinates of L. So I do have a few issues with this question. I'm about to show you why in a second. So let's take a look at the question statement. In the diagram, M is the center of the circle. The center cuts the x-axis at N. Easy to see on the diagram. ST is a tangent to the circle at P. Easy to see also. We have the point R and then L lie on circle. O and V are the x-intercepts of PL. O and V. Okay. O and V are the x-intercepts of PL and RL respectively. Okay, I was a bit surprised, but there we go. That is the information we have, and we are supposed to somehow write down the coordinates of L. So the assumption here, only possible solution to this question, is to assume that PL is a straight line. That is the only way we can be able to find the coordinates of L, which is not given, right? It is not said that PL is a diameter, or it's not said that PM and L are collinear. They do look like they form a straight line, but it is not said. So I have a problem with that, because since when do we just assume? We don't have that information, but we're expected to assume, right? I did say the same thing about equation in mathematics paper 1, that we were supposed to make an assumption that A is an x-intercept, while it is not told. Why it is not, there's no hint to suggest that it is, right? So let's go ahead and find the coordinates of L. But I don't like the equation, because we have to assume that PL is a straight line, which might not necessarily be true. But either way, if PL is a straight line, take a look at this. M is the midpoint, because M is the center of the circle, right? So the distance from P to L is equal to the distance from M to L, right? So we are going to use translation to find the coordinates of L. We don't have to use translation. We can find the equation of the line, right? Because we have P and M. We can find the equation of the line. But if we use the translation, take a look at this. So we have L, we have M, and we have P. So let's look at their coordinates, right? So the x coordinate of M is 1. The x coordinate of P is 3. So the difference in the x coordinates from M to P should be the same difference from L to M, because M is essentially the midpoint of PL, right? So if the x coordinate of M is 1 and that of P is 3, the difference is 2. That should be easy to see. The same should be true with regards to the distance from L to M. So here we must have minus 1, right? Because from minus 1 to 1 is 2 units. From 1 to 3 is 2 units. We can do the same about the y values. So the y value of P is 9. That of M is 3. We can see that the difference is 6. So what must be the y value of L? It must be minus 3. So this is L, minus 1 and minus 3. Obviously, you can use, what do we call this? We can use the midpoint theorem also and find the coordinates of L. But anyway, stories. Let's take a look at 4.2. So 4.2, determine the equation of tangent ST to the circle at P. So we are interested in the tangent of ST. So the tangent ST rather. Let me just highlight that. So this is too thick, let's be a bit slim. So this is ST. This is ST. ST is that tangent. Obviously, we know that the tangent is perpendicular to the radius, right? And MP is clearly a radius. So we can say that the gradient of MP multiplied by the gradient of ST should give us minus 1. So the gradient of ST is equals to minus 1 divided by the gradient of MP, right? But then what is the gradient of MP? The gradient of MP, y2 minus y1 divided by x2 minus x1, right? So we're going to have minus 1 divided by the gradient of MP. So let's take P as our second point. If we do that, y2 minus y1 is going to be 9 minus 3, right? And then x2 minus x1 is going to be 3 minus 1. So this is equals to minus 1 divided by 9 minus 3 is 6. 3 minus 1 is 2. So 6 divided by 2 is 3. So this is the gradient of ST. It is minus 1 over 3. The question says the tangent, actually, not the gradient, but we are a step closer. So we have y is equals to minus 1 over 3 x plus c. We just need to substitute a point on ST, which is P. So if we substitute P of coordinates 3 and 9, we're going to have 9 being equals to minus 1 over 3 x plus c. Well, x is 3 here because we're substituting P. So we have 3 plus c. 9 is equals to minus 1 plus c. 10 is equals to c. So y is equals to minus 1 over 3 x plus 10. We're good to go. Okay, so this is 4.2. Let's take a look at 4.3. So 4.3 says that show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 is equals to 0. Okay, I think this is we should be grateful that this is the equation that we found in the exam. Most people, if they're given this and they're supposed to write it in the other form, x minus a squared plus y minus b squared is equals to r squared, they are going to have issues compared to if you're given if you're given, what do we call this? If you're given the point and the center and you're supposed to write it in that way. But anyway, stories. We know fully well that the equation of the circle, well, I've already written that it is 4.3, can be given by x minus a squared plus y minus b squared is equals to r squared. So our center is M, right? 1 and 3. So we're going to have x minus 1 squared plus y minus 3 squared being equals to r squared. Do we have the radius? Okay, we don't have the radius at this point, but obviously we can find the radius. Yeah, let's just go ahead and, okay, let me just say r squared. Let me find the radius, right? So the radius, we can use MP. We can use MP because MP is the radius. And then this is y2 minus y1 squared plus x2 minus x1 squared. So we're going to have 9 minus 3 squared plus 3 minus 1 squared. Okay, so MP is equals to square root of 9 minus 3, that's 6, so we have 36 plus 4, right? So let's square MP. Let's square both sides because we are looking for the radius squared either way. So MP squared is equals to, this is 36, so MP squared is equals to 40. Okay, so we know that radius squared is 40, right? And then x minus 1 squared, that is x squared minus 2x plus 1. And then we have y minus 3 squared, that is going to be plus y squared minus 6y plus 9. Everything is equals to 40 because r squared is 40. So let's rewrite that in this form that we are supposed to. So we have x squared plus y squared, right? It is there. We're just putting them next to each other. And then minus 2x. It's easy to see how that comes about. Minus 6y. And then plus 1 plus 9 is 10. And then 10 minus 40 is minus 30. So this is what we are supposed to show. And yeah, as you can see, we have that. And then now in 4.4, we are supposed to show that D is equals to 7. So D is the x coordinate of R, where the y coordinate is 1. So, right, we can substitute R into this equation in that form, or we can substitute R there. I think it's better if we substitute it here, right? So we have x minus 1 squared plus y minus 3 squared is equals to 40, right? x is what you're looking for. So we have d minus 1 squared plus y, 1 minus 3 squared is equals to 40. So d minus 1 squared, 1 minus 3, that is minus 2, we square that, we get plus 4. So plus 4 is equals to 40. So d minus 1 squared is equals to 36. I can take square roots on both sides. D minus 1 is equals to, well, plus or minus, okay, d minus 1 is equals to 6. Let me not complicate things. D is equals to 7, right? We have showed that d is equals to 7. If you substitute r on the other equation, it is also fine. It is also fine. You don't have to ask me and say, if I substitute it in the other equation, is it also fine? Will I get all the marks? It is fine. As long as you're not lying. As long as everything is mathematically correct. So that is 4.4. Now let's take a look at 4.5. So 4.5, calculate the size of angle L. So we are looking for the size of this angle. We're looking for the size of this angle. Let me just put a dot there. But we found the coordinates of L by saying that PL should be a diameter, right? And then if PL is a diameter, this here should be 90 degrees. This here should be 90 degrees. If that is 90 degrees, and then we have L, not L, but ML, and then here we have MP. We will end up with equal angles, like opposite angles, not opposite angles, opposite angles opposite equal sides. That's what I'm looking for. We're going to end up with angles opposite equal sides. That's what we are going to end up with. We're going to end up with angles opposite equal sides. Okay, so we will end up with having angle R plus angle L plus angle P being equals to 180 degrees, because those are that's the sum of angles on a triangle. But angle P should be equals to angle R, not R, but angle L rather, should be equals to angle L, right? So by saying that, we can then say angle R plus 2 angle L is 180 degrees. But we know that R is 90, so we have 2L being equals to 90, right? 180 minus 90. So angle L should be 45 degrees. That is 4.5. Okay. And then let's carry on. 4.6. TR is a tangent to the circle at R. So let's just, okay, this is TR. This is TR. It is a tangent to the circle at R. And then the question says, prove that PT is perpendicular to RT. So I'm not going to give myself a headache. I'm just going to find the gradient of PT and find the gradient of RT and compare the two. We do have the gradient of PT because PT same as ST, right, is the same line. So let's just go up and see what that gradient is equals to. Minus 1 over 3. So the gradient of PT is equals to minus 1 over 3. This is from 4.82. Yeah, because PT and ST, coordinates of the same line. So we have that. Now we just need the gradient of RT. So how can we do that? Well, we can find the gradient of MR, because MR should be a radius there. And then that gradient should be perpendicular to that of RT. So the gradient of MR is equals to y2 minus y1 divided by x2 minus x1. What is y2? Let's take the coordinates of R. Y is 1, and then y2 is 1, y1 should be 3. And then the coordinates of D is 7, so we have 7 minus 1. So this is minus 2 divided by 6, which is equals to minus 1 over 3. So the gradient of MR multiplied by gradient of TR should be minus 1. So the gradient of TR is minus 1 divided by minus 1 over 3, which is equals to 3. So 3 multiplied by This is the gradient of TR. Multiply by minus 1 over 3, the gradient of PT, gives us minus 1. So we have showed that these two lines are perpendicular to each other, as we can clearly see here. But in closing, let's go back to 4.5. I'm thinking about something here. Is it that easy? Do we just say L is equals to P? Do we just say L is equals to P? Do we do that? Or we have to actually show first that RL is equals to PT? Do we have to show first that RL is equals to PT? Well, if we have to show first, we have the coordinates of P, we have the coordinates of R, we have the coordinates of L. So we can find PR and find LR to convince ourselves that indeed PR is equals to LR. And then we can use angles opposite equal sides. There we go. Which video do you want me to do next? Let me know in the comments.